Hello, class. We are getting started today on our last video for Chapter 5. I know it's an end of an era, seriously. We're going to do Notes 5.5b and focus on half-angle identities. Think about what half-angle means. Half-angle means you need to take the angle and divide it by 2. That's exactly what we're exploring. So if you could turn back in your packet to that identity outline, that part 2, I have to jump back here on mine. Luckily, I just figured out what page it was on, so I don't have to search for it again. Half-angle identities, and this is for section 5.5. So we want to jot these down so that they get fresh in our brain and so that we understand them. So instead of finding the sine of, this would be helpful to find the sine of 15 degrees because we can work with 30s. So since 15 is half of 30, then that means we'd be able to solve this problem exactly. So let's look at some of our identities. The sine of u divided by 2, an angle split in half, is equal to, interesting, plus or minus the square root of 1 minus the cosine of u divided by 2. We will address this plus or minus idea shortly. The cosine of u divided by 2, a half angle, equals, there it is again, plus or minus the square root of 1 plus the cosine of u divided by 2. Finally, the tangent of u divided by 2, a half angle for tangent, is equal to, you actually have quite a few options here. You get 3 of them. So the first option is plus or minus the square root, big square root, of 1 minus the cosine of u divided by 1 plus the cosine of u. You could also use, that's one option. Another option is 1 minus the cosine of u divided by sine of u. And then finally, you could use, and I'm just going to write it down here, we're going to extend this bracket, the sine of u divided by 1 plus the cosine of u. All of these identities will work for a half angle for tangent. I'm just going to put an A, a B, and a C on them, just so that you have a reference if we need it. Okay, let's head back to our notes. We only have 2 examples tonight. Good for you guys. Okay, the first example says find the sine of theta divided by 2 and the cosecant of theta divided by 2. So we could find the tangent, the cotangent, the cosine, and all that good stuff, but I only have you focusing on 2 of them. So your main idea is that here's what this angle is, and you know that the cosine of this angle is 15 over 17. We don't necessarily know the sine of the angle yet because we don't know this opposite side. But what we want to do is think about cutting this angle in half, like this, and what would we have for the sine of that? So that's what we're doing. All right, I'm going to take that away. So if we want to know the sine of theta over 2, I'm going to go ahead and write sine of theta divided by 2 over here. And I'm going to use my half angle identity. So you go to your yellow sheet or your outline and you look at half angle identity. Well, I have plus or minus the square root of 1 minus the cosine of u divided by 2. So I have to fill this in. And I have to make a decision. Is this going to be positive or negative? The answer is it's going to be positive in this one because we are only working with positive values. This is a real live right triangle, alive and breathing, and all of these values have to be positive because they're all lengths. So if you want to, you can find this side, but I don't know if we're going to need it. I'm going to keep working. So keep working. It's just the positive. Square root of 1 minus, I need the, oh, I'm sorry, this should be a theta. The cosine of theta. Well, the cosine of theta is adjacent over hypotenuse. In our case, adjacent to theta is 15, hypotenuse is 17. So 1 minus 15 divided by 17, all divided by 2. This is where your order of operation skills and your simplifying skills come into play. So we need to simplify this down as much as possible. Square root. Before I start doing anything, I need this to come together. So I'm going to use a common denominator. This is really 1 over 1. So I'm seeing it as 17 over 17. I multiplied by 17 here and right here. I'm going to get a different color and show you how to do that. 17 and 17. So 17 over 17 minus 15 divided by 17. Bigger bar, all divided by 2. That would be the square root of 17 minus 15 is 2, divided by 17. I just subtracted those fractions that have a common denominator, all divided by 2. Keep going. Square root of dividing by fractions. It's 2 divided by 17 times the reciprocal of 2 over 1. So times 1/2. Going to get rid of these 2's. And I'm going to take my math problem up here. So right now I have the square root of 1 divided by 17. Now, this is needs to be rationalized, the denominator. So recall about square roots, that you can take this and apply it to the top and to the bottom. Square root of 1 over the square root of 17. Square root of 1 is 1. The square root of 17 cannot be simplified, but we can rationalize the denominator. So 1 times square root of 17 is the square root of 17 over 17. And that is our final answer. For sine of theta divided by 2. Now, we also need to do the cosecant of theta divided by 2. Cosecant of theta divided by 2 is simply 1 over the sine of theta divided by 2. And many of you guys recognize that as the reciprocal. So it's simply the reciprocal of this answer. All right, so that would be 17 divided by root 17. And then you need to rationalize again. Root 17, root 17. It equals 17 root 17 over 17. 17 over 17 simplifies to 1, and that equals the square root of 17. Okay, just a small reminder. I don't know if you'll have to do it on your classwork, but if you needed to find this side over here, I hope you would know to do a squared plus b squared equals c squared. The Pythagorean theorem. That should be a right triangle. Last example. Use half-angle identities to find the exact values for sine of 7 pi over 12 and cosine of 7 pi over 12. All right, let's get started. This is directing you to use half-angle identities, and you have to follow the directions. So it is saying it wants you to think of this as sine of theta over 2 is equal to this, sine of 7 pi over 12. It wants you to use this identity to evaluate this problem. Well, if you recall that when you are working with sine of theta divided by 2, you're going to have to know what theta equals. So I hope you are seeing these two things as equivalent, and your job is to find theta. Okay? So theta over 2 is equal to 7 pi over 12. Now, how are we going to solve for theta? This is a proportion. We're going to cross multiply. So 12 theta equals 2 times 7 pi, which is 14 pi. I'm going to divide both sides by 12. Theta equals, oh, this is nice. 14 over 12 is 7 pi over 6. That works out conveniently because 7 pi over 6 is something that you're used to on the unit circle. So what I want to show you that you're doing, if you have to use half-angle identities, you are going to say that the sine of your theta is 7 pi over 6 divided by 2. I just put theta in here. And the reason why I'm emphasizing this is because I believe it can be really confusing. Let's remember that what you're truly evaluating is 7 pi over 6 divided by 2 is really times 1/2. So this is equivalent to the sine of 7 pi over 12, which is our original problem. Okay, so that was a long, drawn out explanation of saying your job is to find what theta should be in order to use half angles. Okay, so what you should be focused on right now is this right here. Okay, your theta is 7 pi over 6. It's not what you're evaluating. 7 pi over 6 divided by over 2 is what you're evaluating. Okay, I'm going to go on to the next page. So the sine of 7 pi over 6 divided by 2. Go to your identity sheet or your identity outline and look for half angles. The answer to this problem or identity is plus or minus the square root of 1 minus the cosine of theta divided by 2. And I'm double checking. Plus or minus square root of 1. Now, remember what our theta was? Plus or minus the square root of 1 minus the cosine. Your theta is sitting right here. It's hanging out right on the top. Is 7 pi over 6 divided by 2. Now, this problem is not so simple with plus or minus. You really have to think about what you're doing. In this case, the original problem is the sine, I gotta look, of 7 pi over 12. All right, I need you to draw that on the unit circle. 7 pi over 12. What quadrant would that land in? Draw the angle. And here's 0. Where would 6 pi over 12 be? 6 pi over 12 is half of pi. You're just a little bit further. So your sine value, your y value, is positive up here. So this is actually a positive answer. You do not get to have the negative answer on this one. All right, here we go. So square root, this is all just simplifying in unit circle. The cosine at 7 pi over 6, I'm going to go back to my unit circle. The 7 pi over 6 is right here, a little bit further than 6 pi over 6. The x value is negative root 3 over 2. The y value is negative 1/2 here. So I'm using my x value. So 1 minus negative root 3 divided by 2, all divided by 2. Time to simplify. The square root of 1 plus the square root of 3 divided by 2. Careful with your fractions. All over 2. If I am going to simplify this, I need to get a common denominator on the top. So working a little bit faster this time. 2 over 2 plus the square root of 3 over 2 divided by 2. 2 plus root 3 divided by 2. Hold on. Nate Stearns is here.